All right, class, we're continuing our discussion on 3.1 on solving linear equations. We went ahead and we did an overview of linear equations. Now we're going to move on to solving linear equations in standard form. So first of all, let's ask ourselves, what does it mean to solve? So far, we've been doing operations because we've been dealing with expressions. Now we're going to actually go ahead and we're going to solve equations, which means we're going to solve for the variable. So the key thing you want to remember when solving is that solving just means that you're finding all of the values of the variable that satisfy the equation. So what does that actually mean? If we have an equation like 3x minus 15, you want to ask yourself, what are all of the values of x that would make this equation true? Okay, so that's what you want to make sure that you ask yourself every single time you go up against an equation that you have a variable. You want to ask yourself, what does x have to be for the equation up here in this case to equal 0? You want to say, what can I do to make x equal, to make this equation equal what it actually equals, okay? In that case, the only thing that you can change is the variable, which in this case is x, okay? So just ask yourself every single time, what does x have to be for the equation to actually equal 0? All right? So I have two rules for solving equations that I want you guys to remember. Okay, these are the two rules, basically all of algebra simplified. Okay, so we're actually going to call these the Cheaty rules. Just remember these two rules and then you'll be good, okay? Isolate the variable, first rule, okay? You want to get the variable by itself. If your variable is x, you want to get x by itself. And then number two, most importantly, whatever you do to one side, you have to do to the other, okay? And that's the exact thing that you do to one side. You're going to do the same exact thing to the other side. What do I mean by sides? I mean the sides of the equal sign. Okay, your equal sign is going to divide your equation into two hemispheres. Whatever you do to one hemisphere, you're going to do to the other hemisphere, okay? So let's go ahead and let's solve one of these. If we're dealing with this equation up here, which was 3x minus 15, we want to ask ourselves, what does x have to be for the equation to equal 0? Because that is the answer to this equation. It's 0. What does x have to be for the equation to actually equal 0? And a quick tip is to work from the outside in, okay? Always work from the outside in. That means start with the things that are least attached to x. In this equation right here, the thing that is least attached to x is going to be the 15, okay? And in fact, it's a negative 15. So this negative 15 is going to be what is farthest from the x. So that's what we're going to have to move to fulfill the first rule, which is to isolate the variable. Okay, so I'm going to go ahead and rewrite this equation. 3x minus 15 equals 0. What can I do to isolate this 15, to take this 15 away so that I can isolate this 3x, right? We're working from the outside in. And you guys probably already know the answer to that, and that's going to be to add 15. So if I add 15 to negative 15, that 15 cancels out, right? That 15 is gone. But whatever I do to one side, I have to do to the other. Now, a couple of times people make mistakes because they think, okay, I'm adding 15 to this side, but then on the other side of the equal sign, I have to do the opposite. That's not true. Whatever you do to one side, you have to do the same exact thing to the other side, okay? So if I am adding 15 to this side, I have to add 15 to that side, which means that I'm going to now get 3x. This 15 cancels out, and then you're left with 15 over here. Okay, and since we're working from the outside in, we're trying to isolate our variable. Now we ask ourselves, what do we have to do to further isolate x? Okay, we want x by itself. What I have to do here is that the only way to cancel out this 3 that's attached to the x is to divide this 3 by 3. Why? Because 3 over 3 equals 1. And if I have 1x, then that just means that I have x, okay? So whatever I do to here, this 3 divided by 3, that's going to give me 1x on the left hemisphere. And then whatever I do to one side, I have to do to the other. It doesn't mean I'm dividing by 15. It means I'm dividing by 3. I do the same exact thing to one side as I do to the other. 15 divided by 3 is going to equal 5, okay? Now here you have 1x equals 5. which literally just means that x equals 5, okay? And that's your final answer. So go ahead and work on example 2 on your own, and example 2 is going to be found in your books on page 128, okay? Example 2 on page 128. Go ahead and work that out. Pause the video, work that out, and then we're going to move on to the next part. All right, so you should have figured out example 2. And example 2, the answer is that x equals -9. All right, we're going to move on to example 3 now. Example 3, 5x minus 12 equals 0. We're going to ask ourselves the same exact things that we asked ourselves before. What does x have to be for this equation to equal 0? Whatever I do to one side, I have to do to the other in my effort of isolating the variable. So the most farthest away thing from x, right? We're working from the outside in. The thing that is least attached to x is going to be this -12, which means I'm going to add 12 to both sides, right? Because -12 plus 12 is going to give me 0. That 12 is out of there, so I'm adding 12 to both sides, and then I end up with 5x equals 12, right? Now I ask myself, what do I have to do here to this 5 that's attached to this x to get rid of it? I have to divide by 5. If I divide by 5, that cancels out. I divide by 5 here. Now I'm left with x equals 12 over 5.